Let's discuss the question number 10 from test series 4. This is from machine design. So a journal bearing is given of diameter 100 mm and the length is 150 mm long, and it carries a radial load of 7 kilonewton. So let that be W, and the speed is basically the 1200 rpm. So you have the journal bearing, which is inside. You have a shaft inside a journal bearing, okay, and if you look at the side view, you will have some amount of eccentricity between the shaft, though I have drawn clearance very high, but clearance will be in microns. Okay, so this is basically the radial load which might be acting sideways, but I have drawn it vertically. Don't confuse this with the weight of the journal bearing, it's just the radial load. Okay, so there will be fluid in between the shaft and the bearing, and because of the viscosity of the fluid, there will be the friction that is developed as the shaft rotates around the shaft rotates with some RPM, which is 1200, which is given as 1200 RPM. So now the average friction force is basically your mu, the friction coefficient, into the load, and that is nothing but mu into W. And so the power wasted in friction will be basically my average frictional force F into the surface velocity. Okay, so surface velocity of any point on the, that will be same. So surface velocity of any point on the bearings, on the shaft center, that will be same. So that is nothing but F into, so this is nothing but R into omega, and R is basically my diameter of the bearing on the diameter of the shaft is same, because there will be very small difference, which is nothing but your clearance, and clearance, as I told you, it will be in microns. So the diameter of the bearing and the diameter of the shaft will be same. Omega can be written in terms of speed as 2 pi n by 60. Okay, so this gives rise to B. So this power P is given, the power wasted is given as 1.2 kilowatt. So that is nothing but F. Now for F, let me substitute this. So mu into W into 2 pi n by 60, let me write d by 2 outside. Okay, so power given is 1.2 kilowatts, so that is 10 power 3. Mu is what is asked. W is your 7 kilonewton, so let me write 7 into 10 power 3 into 2 pi, speed is 1200 rpm by 60, into d, diameter is 100 by 2. Let me just put it in meters, so it will be 0.1. Okay, so this, when I use calculator, this comes out to be close to 0.027. So let's look at the answer. It's B. Option is B. Thank you.